Now, there are many things you can do with integration, and one of the more exciting ones is finding volumes. Suppose I had some strange shape, and do you see that in each one of these shapes I have an axis, so that I have through this axis? It's possible to um, determine the volume of these shapes using a solid of revolution. So let's start with a disk. If I give you a disk and it has a thickness W and a radius R, then that volume is going to be the area of this side right here, and this is a circle. So the volume is going to be the area times the width, right? And what's the area of a circle? Well, that's just pi r squared. Now what we're going to do is the exact same thing, but instead of W, we're going to have a dx, a delta x, and instead of r, we're going to have a function of x. Now you see, I didn't matter what my shape looked like, because what I'm going to do is I'm going to find a differential volume, which is going to be pi r squared, where r is the distance from the axis of rotation to the top of the rectangle, or you can think of this as the height of the rectangle. RR is our representative rectangle, and delta X is our thin little strip. So if I have a thin strip and I rotate it about this axis right here so that I get this disk right here, then the volume of this disk, this solid disk, is pi r squared delta x. And if I add them up, so if I add up all the delta v's, this will be adding up pi r squared delta x. And then if I take the limit as n approaches infinity of the sum of the delta v's, I'm going to get pi times the integral from a to b of r, and instead of r, I'm going to use f of x squared dx. And lo and behold, that is exactly what we do when we use the disk method. And we call it the disk method because we're making disks. I'm going to need you to identify your delta V for the disk method and then give me the formula. Now, it is also possible for us to decide to rotate about the y-axis, and if we do that, then this r is going to be, r of y is again the height of the rectangle. And instead of delta x, we're going to have delta y. And the book uses C to D. I use A to B for both of them. It does not matter. But here we'll be having the disks rotated about this y-axis. Now here are steps that I would like for you to follow. Draw a curve, identify the axis of rotation, and to identify the axis of rotation, I want you to put a little arrow like this. So if I'm rotating about this line right here, this is how I want you to show me that you're rotating about the x-axis or about the y-axis. Draw a representative rectangle. This is very important. And when you draw your representative rectangle, you're going to identify dx or dy. How? Because you're going to put delta x and delta y. I want you to draw r on the graph and then write r equals, and this is usually going to be f of x or f of y. And then identify your limits of integration, write the integrand, and do the problem. So let's do a problem. Suppose I want to find the volume of the solid formed by revolving the region of the graph bound by f of x is the square root of the sine of x, and the x-axis for x between 0 and pi. So we draw the graph, draw the representative rectangle. So I see I have delta x. So I know I need to put my limits in terms of x. So A is going to be 0 and B is going to be pi. Now what is my radius? Here is R, and I'm going to draw R. R is the height of this rectangle, and I'm going to write R of x is equal to, well, it's top minus bottom, so it's going to be the square root of sine x minus 0, so it's just the square root of sine x. Now I know it seems redundant to do it here, but when we do the washer method, you'll see why I am writing it this way. So what is my differential volume? The volume of a disk is pi r of x squared times delta x. So I need to make sure I have that delta x right there. So this is pi r of x squared is sine of x delta x. So the volume is going to be, I'm just going to integrate this, pi times the integral from a to b of r of x squared, and I'm going to put brackets here, dx. And yes, I need to see your generalized formula. So this is equal to pi times the integral from 0 to pi, r of x squared. Now if you've written this, it's just a matter of plugging it in. Sine of x dx. So this is going to be pi. The integral of sine is minus cosine. It's going to be evaluated as 0 and pi. So this is going to be minus pi times the cosine of pi minus the cosine of 0. Now, this is going to be minus pi times negative 1 minus 1, or 2 pi. Please note, your volumes are always positive, and sometimes they're not very pretty. Sometimes they look they're going to have pi's and weird numbers in them, but that's okay.